In this example, we are going to find partial sums of geometric series. And so right away we can see that this is a geometric series because to go from 5 to 10 we'd multiply 2, 10 to 20 we'd also multiply by 2. So we're going to do the sixth partial sum in 3 different ways just to kind of outline how we've done this in class. The first way that we learned is basically just writing out the list of all 6 terms and adding them together. So we would have 5, 10, 20, 40, 80, 160, and 320. So that's 1, 2, 3, 4, 5, 6. Oh, did one too many. There are my first 6 terms. Now we could add them all up, and we would end up getting 315. Now, this method is easy. It makes sense. However, here in a second, I'm about to find 20 terms, or the 20th partial sum, where this would take a long time. So next we learned to find partial sums using a summation. And so we can tell our calculator to start at the first term, to add through the first 6 terms, but then we had to give it a formula. And so since this is geometric, we're going to follow this form where we take the first term times our common ratio to the n minus 1. Our first term is 5, our common ratio was 2 to the n minus 1 power. To do this on your graphing calculator, you would go to Math, 0. On our calculator, we'll use the variable x, same thing as n. We're going through the 6th term, and then we would type in our equation, 5 times 2 to the power of x minus 1. And we also get 315. So these are 2 ways to find the 6th partial sum. However, when we were trying to work backwards, we found a third formula. And so that third formula was this guy right here, where we take the first term times the quantity, 1 minus your common ratio to the n, divided by 1 minus your common ratio. And so my first term was 5, and I'm going to multiply that by 1 minus 2 to the nth. And instead of an n, that should actually be a 6. Since we're finding the 6th partial sum, divided by 1 minus 2. So I will get 5 times, you take 1 minus 2 to the 6th, which is going to be negative 63. 1 minus 2 is negative 1. So negative 63 divided by negative 1 will turn into a positive. 5 times 63 will be 315 as well. So all 3 answers match. All 3 methods work just fine. However, these bottom 2 are going to be the most efficient methods, so you don't have to find every single term before you add them up. So the directions say now find the 20th partial sum using the most efficient method. So I would say that either of these are most efficient. It's really up to you which one you prefer. I'll go ahead and first just use the summation. We're starting at 1. Now we're going through the first 20 terms, and again we already have the equation written. You can also use Desmos to find these sums if you don't have a calculator at home. So from here, I'm going to clear that out. If you go into Functions, Miscellaneous, you will see the sum right there. We're telling it to start at the first one, count through the first 20 terms, and Desmos won't find it unless you put your function in parentheses. So just be sure that you do that. Taking 5 times 2 to the power of n minus 1 is going to need to go here. Now notice that it just put me outside of the parentheses. So when you go to do this, you need to first hit your exponent, then parentheses, n minus 1. And then once I deleted that little extra space that was right there, I end up getting my sum, which looks like 5,242,875. So quite a large number. So that's what this summation gave us through Desmos. And we'll go ahead and use the formula just to do it one more time in another way. And so if we use this formula, we're finding the 20th term. We would start with the first term, which is 5, times 1 minus our common ratio, which is 2 to the nth power, which is 20 over 1 minus 2. So I'm going to go to my calculator to do this. I'm going to first type in the numerator 1 minus 2 to the 20th power. I'm going to divide that by a -1, and I'm going to multiply that by 5. And we get the same answer, so we know that we're correct.